Alright guys, we're going to be graphing inverse functions today. So it's going to be graphing, but the new part is we're going to deal with inverses. Let's take a look. Okay, so an inverse function. Remember when we talked about functions in Unit 1? That's when we had our domains that went to our ranges. So we had x that went to our y's. We had inputs and outputs. When we have an inverse, that's when they flip-flop. Okay, so our range becomes our x values, or our inputs, and our domains become our outputs, or our y values. Okay, for functions, we used to say functions look like this. Okay, so for an inverse, we denote it with a little -1 there, and we just read that as f inverse of x, or the inverse function of x. Okay guys, the first thing that we're going to graph inverses of are lines, or linear functions. I have it written down there. Linear functions are those y equals mx plus b. So remember b, that was your y-intercept, and m was your slope. So we're going to graph these the same. We're going to plot the y-intercept and then use slope, rise over run, to get the other points. Then for inverses, the difference for inverses is we just talked inverses when the x and y flip. So we're actually going to make a table and flip our x and our y points, and then we're going to graph our new function. So that 3 and 4 are kind of the new steps. Okay, so first off, I'm just going to graph this. My b, or my y-intercept, is +6, so I'll go up 6, because that's my y-intercept. And then I'm going to graph it with the slope, which is -1/4, so we'll go down 1/4. And then I'm also going to go down 1 again over 4. You can do I usually go about 3 points. Okay. Now, that was my function. Okay, that's my function. Now, I'm going to do the inverse. Now, in order to do the inverse, okay, I'm just going to go ahead and pick 3 points, or those points, and write them down. Okay, so we're just going to go ahead and pick those points. So the first one is at 0, 6. Okay. This next point was at over 4, 5. The last point was over 8, okay, up 4. Okay. Now, to do the inverse, I'm going to go ahead and I'm going to flip the x, y table. So I'm going to have my x and my y's are going to flip-flop. So this is going to be 6, 0, 5, 4, and 4, 8. Now we're going to go ahead and plot these points. So I'm going to plot the point 6, 0. Then I'm going to plot the point 5, 4. Then I'm going to plot the point 4, 8. Okay, now I'm going to go ahead and draw in my line. Okay, now the red one is our answer. That's our inverse, f inverse of x. Okay, the black one was just our original. Okay, so a lot of these ones will ask you to graph the original and then its inverse. So the original is the black one, the inverse is the one with the flip table. Now the other thing that we'll graph will be inverse functions. We're going to do the exact same way that we've always graphed radicals, or those little curve shapes. Okay, but then we're going to have to flip our table, or flip the points. So let's look at an example. Okay, so now when we're graphing this, I did put the table of the parent function on your notes in case you needed it. That was 0, 1, 4, 9, and then 0, 1, 2, and 3. So let's plot those points. Okay, but we're actually going to have to do something with those points. We're going to have to shift them. That -1 tells me down 1. The -2 tells me to the right 2. Okay, so I'm going to shift all those points. And then that is my new graph. Okay, those original points, that parent function was just to help me out. I don't need those points anymore. Now I'm going to go ahead and make a table of those points of that graph. Okay, so we have our x and our y. Okay, so the first one is 2, -1. The next point is at 3, 0. The third point is at 6, 1. And the last point is at 11, 2. Okay, now to do the inverse, we're going to have to flip our x and y table. So I'm going to do it in red. Okay, so my next points are going to be -1, 2, 0, 3, 1, 6, and 2, 11. So I'm going to go ahead and plot those points now in red. So -1, 2, 0, 3, 1, 6, and 2, 11. Okay, now I'm going to go ahead and draw in. Sorry about some of those points. My stylus is being weird. But that is our graph. Now, that is our f inverse. Okay, and then the black one was our original. Just f function. Now, you might kind of notice, but when I look at these graphs, okay, when I flip the x and the y, our graphs, if you kind of notice, it's like they're reflective of each other down a line that kind of goes diagonal like that. That's y equals x. Okay, that's kind of a hint that you're doing it right. Is your graph should look like the inverse is flipped across that green line. So that's always kind of helpful to tell if you're doing it correctly. And that's kind of a special case for inverses. Okay, suppose f of x is a function. F inverse is not always going to be a function. We're going to talk about that more later, but just know that just because one's a function, it does not mean the inverse is automatically a function.